simple statements in SQL. You can work with DDL, DML statements in SQL, right? So I will get you some introduction to SQL, right? So till the other students, they joined the whatever we have discussed in the last class, right? So last class we discussed about the three schema architecture of a database management system. We discussed about physical level schema, logical level schema, and external schema and external schema or view level. And we discussed something about physical data independence and logical data independence, right? Right. So
Yes, sir.
Yes,
yes.
sir.
So Xavier,
Sir, it's Evan. Is it?
right?
Is,
Yeah, you're audible. Right. So can you say something about physical data independence? What do you mean by physical data independence?
so physical data independence is like changes only in the database, while as the other one, logical data independence is like changes in the structure, like the logical structure of sorts.
So logical means you are going to change the structure of the database without causing the application programs to
Yeah,
be
yeah.
rewritten.
Yes,
So
sir,
the
yeah.
thing, so you are going to make changes in the conceptual level. We don't have to make any changes in the view level. It's known as logical data independence. So I should be able to add some attributes or something to a particular relation without causing the application program to be rewritten. It's known as logical data independence. Can you repeat what you said for physical data independence?
For physical data independence, changes only in the view of the database.
Physical data independence means
No
I'm going
change in
to
the storage details
Storage
without the
structure
change in
and
view
details.
level or external level.
right. Correct. So Saloni is correct. So you need to change the storage location of a database, right? So you may store it in a database. You may store the database in a memory, or you may have stored it in a disk file, in a storage disk without causing the. You can change the storage location without causing the applications programs to be rewritten. It's known as physical data independence. Subramaniam. Subramanian, right? So
Yes,
can
sir.
you state the three levels in schema architecture? Physical level, logical level. What do you mean by physical level? What do you mean by logical level? And what do you mean by view level or
View level.
external level?
Yes, sir. So physical level, it's the lowermost level of the architecture, sir. And
Right.
in that, it actually says like how we are storing data and that, and not much about like what kind of data or like the relation between the data as such. And the logical level is based on the relation between data that is stored in the database, like whatever, however are the data that is present in the database, how are they related amongst each other, and that's logical level, and that's the middle level of the architecture. And then the last one is the view level, which is the highest level of architecture, and in that it's more. Am I audible, sir?
Yeah, you are audible. Yeah, right.
Okay, sir. So view level, in that it's the in that the security. It's more based on like what kind of data that a user can access, and it's more based on the permissions that one has in that database, and it's the highest level of architecture, sir.
Right. So I will add some more points, right? Physical level, it deals with the storage details, access patterns for a particular database. It also deals with the data structures that are used to represent the data, right? So physical level means it deals with the storage structure and access patterns for the particular data, as well as the data structures that are used to represent the data. And right, conceptual level, or uh, you gave the correct answer, like what's the relationship that exists among the data, right? And view level also, right? So we need to give a different perspective view of the same database to different users. And view level or external schema deals with creating virtual tables for different types of users who are accessing the system, right? Right. So that's what the first topic that we discussed in the last class. And the second topic that we discussed was about data models, right? So we studied about relational model, entity relationship model, object relational model, and semi-structured data model, right? Nanda Kishore, can you explain the relational model?
Yes, sir. So relational model is a basic kind of database system where we group the data which we get based on the IDs which they have. For example, in the class you said we have two tables which have student ID and some other ID related to the student, and we are grouping the data based on the ID which we get from the data which are collecting. So it's basically grouping all the given data points into certain non-editable format based on the ID which we get from the ID which belongs to the student.
Right. I will give some other way of defining it. So we are going to use tables to represent the data.
Yes, sir. Yes, sir. We use tables. Yeah.
So in a relational data model, we use some tables to represent the data, and we use tables to represent the relationship between the data, right? So whenever you have multiple relations, so we need to use multiple tables to represent the relationship between the data. The rows are known as tuples or records in a table, and the columns, they are known as attributes. So you have a primary key attribute that uniquely identifies a particular record in a table. So you need to know about foreign key also. Whenever you are going to refer the primary key of one table in another table, it's known as a foreign key, right? So for example, I have a relation student ID, student name, age, and so on, and I have department ID, which is going to be the foreign key of department table, right?
Yes, sir.
Then,
I understand.
Right. So whenever you are going to refer the whenever you are going to refer the primary key of one relation in another relation. So department ID is the primary key of a department relation with attributes department ID, name, location, contact number, and so on. So I am referring the primary key of one relation in another relation. It's known as foreign key. Right. So tables, that's it. So all the commercial database management systems, they do follow this relational data model. So it's a very popular model, right? So the next topic was about ER model, right? Nitin Gupta. Nitin Gupta. Right. Rohan Kumar. Rohan. Right. Samuel.
Yes, sir.
Samuel, can you say something about ER model, entity relationship model?
I'm not sure, sir. I don't.
You don't. So I think I have shared all the materials in the teams, right? So once the class is over, like you people can have a look on it. Huh?
Yes, sir.
Oh, okay. So Sneha Rao.
Yes, sir.
So
Uh,
can you say something about ER model?
yes, sir. Basically, it's a model in which all the data points, like whatever data we have, and which are stored, are usually they're referred to as entities, and each of them have certain attributes that make up the domain completely, and all the relationship between the entities are mapped well with like like a star schema sort of situation.
Right. You have said something about data warehouse.
Sorry, sir.
So what do you mean by star schema?
So basically, it's a sort of an ER diagram that they use to, in which like the central fact table connects multiple dimensional tables together to connect the attributes and show the relationships.
Right. So it seems that you have done something, some course in data warehouse, huh?
No, so
While
I was
teaching.
actually studying for these companies that come for interns, so I just read somewhere.
Right. Okay,
Yes.
good. So entity is an object of interest in an system. So entity, it is an object of interest in a system which may have a physical existence or it may have a logical existence. Right. So some like a student is an entity in an university, like faculty is an entity in an university, department is an entity, right? So even your grade sheet can be an entity, right? So something can have physical existence or something which may have logical existence. An entity is described by a set of attributes, right? So we'll study more about ER model. We have a separate chapter about ER model where we'll discuss about the different types of attributes, like simple attributes, composite attributes, right? So simple attributes means attributes that cannot be further subdivided, whereas composite attributes means, for example, name of a particular student can be further subdivided into first name, middle name, last name, right? Similarly, address can be further splitted into door number, street name, city, and so on, right? So ER model, you need to know what is meant by an entity. Entity is an object of interest in a system which may have a physical or logical existence. Then you have an entity is best described by a set of attributes. And we also have a relationship that connects multiple entities together, right? So there exists some relationship between the participating entities in a relation, right? Then we discussed something about object oriented model and object relational model, right? Yashwant, can you state the advantages of object oriented model? Vishwanathan,
Yes, sir.
right? Can you brief us about object oriented model or object relational model?
Yes, sir. So, object-oriented model is more based on real life. So we have attributes which can represent either like real life, any real life object, and then we have methods and attributes that are in the same what do you say in the same class. And then there is some sort of relation between different classes that exist in the database, and those are called links. So two or more objects can be connected through links, and yeah, and then methods can access all the information that is there in the class, and then they can manipulate the data, and also they can define the relation between one or more classes that exist in the database.
Right. So what's the advantage of object model, object oriented programming paradigm?
All the objects and like the relation between the objects and the data, everything is contained in a single unit, so it's easier for us to access.
Right. So you are correct. The thing is that generally not any.
Reusability.
Yeah. Right.
Yeah, I think reusability, and we can use existing class added to another class library, so it'll save cost of production.
Right. So Saloni is correct. So Vishwanathan, you are partially correct. The thing is that, as you said, you have data and the methods that act upon the data, and right. So you bundle it together in a class, and an object is an instance of a class. So the advantage of object-oriented programming paradigm generally is like reusability, so that if something is available in the class library, you can plug and play it. So automatically the product development time is being reduced, the cost of the product is being reduced. Right now, most of the models we also have object relational model. So it combines the features of object-oriented programming and relational programming paradigm. We have this object relational data model. So relational model, you can go for scalability. You can store large volume of data. You can store more number of records. And so object relational data model combines the features of best features of both object oriented programming paradigm and relational programming paradigm, right? So the last thing was like we were discussing something about semi-structured data model, right? So I want any one of you to explain what do you mean by a semi-structured data model. Right.
So like for
Okay, so in
example, in
Yeah.
So like there's no certain separation between the schema that we use and the data there is. So it depends on how much data that we have, the structure that we define the structure later on, and depends on the purpose that we're using the data for. So it's
Right.
kind of a flexible format.
It's a flexible format, right? So it's a flexible format. How it is flexible, Yashwan? Sorry, Vishwanathan. How it is flexible?
Like it does not need to obey like the tabular format that we usually have in a database management system.
Right. I think you can.
Sir, maybe different entities means same entity can have different kind of attributes.
Correct. So Ritik Mittal. So
Yes, sir.
your answer is like correct, right? So you have a student entity, right? So for example, you all belong to the student entity set. So I may have different set of attributes for different entity sets, right? So for example, for one student, I'm going to store his roll number, name, and email ID. Whereas the other student, I'm going to store roll number, name, and contact number, right? So for one student, I have contact number. Whereas for the other student, I am going to have email ID. I don't have his contact number and so on. In the conventional relational format, we need to go for some not null values to store data that is not available. And like a conventional relational model, you need to have all the information to be filled in a table. Whereas a semi-structured model, it works with semi-structured data. So we have an markup language, extensible markup language for storing semi-structured data. So right, so you have entities of the same set. They may have some different set of attributes. So that's the advantage of going for a semi-structured data model, right? Right. So we'll start with today's class. Right. So in the first few classes, we'll be